Okay, so I've noticed that this example 4 was a duplicate of the previous, so we have to cross it out and move on to the next one. Okay, so in this example 5, it says identifying the characteristics of a quadratic function from its graph. It says graph this function and then solve this inequality. Okay, so we can do this. All right, so I'm going to give you my general thought process when I'm graphing functions for the most part. Okay, and it's essentially the same thing over and over with a few minor tweaks based on what's given. So things that I typically look for when I'm graphing a function, the first thing I usually look for are my intercepts. So and between the two intercepts, the first one that I usually find is my y-intercept. Okay. Now if I'm looking for my y-intercept, how do we find the y-intercept? What do? We set we set x to 0. So that's why I choose the y-intercept more often than not. That's easier to find. It's easier to find than the x-intercept. For instance, if you look at this example and if we set x equal to 0, notice this first one's going to go to 0. That's going to go to 0. Usually, only thing we're left with is a constant function. So when x is 0, y is negative 1. Okay. So the y-intercept should be 0, comma negative 1. Okay. So then the natural flow. Okay, if I have my y-intercept, then naturally we can also talk about what? The x-intercept, okay, or intercepts. All right. So before we go forward, again, let's think about this. Now, if we're looking at this example, what's the highest degree? The highest degree or exponent is 2, so it's quadratic, so it should be a parabola. Okay. So then it's a parabola. Which way does it open? It opens upward because the leading coefficient is 3, which is positive. But since we don't really have a sense, okay, yeah, we don't, because that moves it down. We're not 100. We know we have an upward facing parabola. Okay, and then the y-intercept is negative 1. So if the y-intercept is negative 1 and it opens upward, then we should have two x-intercepts. Again, think about it. So let's look at this. Just kind of playing around with some of the notions. Say this is my xy plane, all right? And then we have some parent function, some parabola. All right. So now we said it's a parabola that opens upward. If the y-intercept is negative 1, now we could drop it down. It could be like this. But if the y-intercept is negative 1 and it opens upward, then we should, at somewhere, like either here, somewhere we should have x-intercepts. Okay, so that's just conceptually, it should work. All right. So the x-intercept, so to find the x-intercept, what do? We set y to 0. So for the y-intercept, we set x to 0. For the x-intercept, we set y to 0. So if we set y to 0 and solve, we'll get 3x squared minus 6x minus 1. We're setting that equal to 0. Okay. So if we wanted to solve, let's see, if we tried to factor, that'll be negative 3. So we wouldn't be able to factor it directly, at least not that I see. It's no common factors. All right, I think this will be a great time to do a demo on putting this in standard form. Let's see if we can put this in standard form. So to put a quadratic in standard form, what we do is the technique of completing the square. So you should, coming into this course, we have prerequisites and placement exam. So coming into this course, I assume or I expect you to already know or be comfortable with factoring. Now I know, I don't expect you to be super proficient, but you should have, some knowledge of the factoring techniques. So like in this one, I'm going to use a technique called completing the square. Now, if we do completing the square, usually it's something like a b over 2 squared plus or minus. But the first thing we do if we're going to do completing the square, we need to make that leading coefficient a 1. So we need to factor out a 3 from everything. Okay. So if we factor out 3, we'll get 3 times, it's going to be x squared minus 2x minus a third, okay, equal to 0. So notice, these two lines are equal. If you multiply the 3 back, you'll get the above line. Okay. So now the completeness square, our b is going to be negative 2. So we say negative b over 2 quantity squared. So the way we're going to write that, so the completeness square step, we're going to have the 3, we're going to have the x squared minus 2x. So b over 2 squared, so then we want to say plus b over 2 quantity squared and minus b over 2 quantity squared. So the idea here is that we're basically adding 0. When you add something and take that same thing away, then it's like adding 0. So, but we're adding 0 in a form where we can manipulate it and do what we need to do. So so the b is negative 2, so then we'll say plus negative 2 over 2 squared and minus negative 2 over 2 squared. And then we still bring everything else down. So then the negative 1/3 comes down, equal to 0. Okay, so we added something and then took it away, so we're just adding 0 in a certain form that we can use. Let me add a page. All right. So then what this allows us to do is do completing the square on the first term. So we got 3 excuse me. So we have 3x squared minus 2x. Negative 2 divided by 2 is negative 1. Squared is positive 1. So plus 1 minus 1. And then we have the minus 1/3 equal to 0. All right. So now, if we look at the first 3 terms right there, we can do completing the square, which is, well, the technique that we're using now is called factor by grouping. So those first 3 factor into, so then we'll have 3, let's see if we can get this going. We got x and x. Tell me about the signs. Are they the same or are they different? And they are the same because of this plus here. Okay, so they're either both positive or both negative. All right. Oh, then we're looking for two numbers that multiply to give us 1 and add to give us negative 2. So it'll be minus 1 and minus 1. Notice these multiply to give us the positive 1 and they add to give us the negative 2. Then we bring down negative 1 minus a third. So I think that's 4/3. So we'll have a negative 4/3 equal to 0. Okay. So then if we put it in the correct form, we'll have x minus 1 quantity squared minus 4/3 equal to 0. And we need to keep in mind this 3. Okay. Let's answer the question. Oh, are we still trying to? Oh, okay. I think I kind of skipped to another form. We never found our intercepts. Oh, but we can find it from here actually. So the thing with completing the square in the form that we have, we should be able to easily find the intercepts. So the y is 0, so let's solve for x. Now we've isolated 1x, so we just kind of work backwards. Divide by 3, we'll have x minus 1 quantity squared minus 4/3 equals 0. Add the 4/3, x minus 1 quantity squared equals 4 by 3. Then square root both sides, you get x minus 1 is equal to plus or minus the square root of 4/3. Then x is going to be 1 plus or minus, I'm just going to leave it as 2 over root 3. So let's see. So these x values should give us 0. Let me see. So these should be our x-intercepts. Should give us a y value of 0. I'm actually going to check this because the number is a little interesting. So I want to check this. So what I'm going to do is type in the original here, which is 3x squared minus 6x minus 1. I want to quit, and I want to plug in, try these values. So I'm going to go to variables, y variables, number 1, y1. So the first one I want to test is 1 minus 2 divided by the square root of 3. Okay. So when that's our x, what value should we get? We should get 0, and we do. And then we're just going to quickly check the other one. When we plug in the plus, and we still get our 0. So these are indeed our x-intercepts. So, you have 1 minus 2 by root 3, comma 0, and then 1 minus 2 by root 3, plus, comma 0. Okay. We're not done. We're going to continue momentarily.